So yesterday's class we have seen about centerless cylindrical grinding we have seen. So today we are going to see about centerless internal grinding. So maybe see in this image, in this slide, maybe here this image is there. So whatever this hatched portion, so this is actually the workpiece. So there is a big pipe is there which having some thickness. So in that the grinding internal surface is grinding. So normally yesterday we have seen for cylindrical grinding, for external cylindrical centerless grinding, we used to have two wheels. So one is grinding wheel and one is the regulating wheel. But here, so because grinding has to do internal part, so grinding is this is the grinding wheel. So to hold this workpiece, we not only required one, we need three wheels are required. Means other than grinding, three wheels are there to holding this workpiece because there is no center. So this is a centerless grinding. So centerless grinding means there is no center like holding the workpiece like normal center grinding or surface grinding, like in your lathe, right? So in lathe workpiece, we are holding in the chuck, and other end of the workpiece, if it is very long, we are holding in a tailstock. So, but in centerless grinding, we don't have any centers. So, because in what happened in somewhere when you are going and working your work at the sites, so maybe at wherever you are implementing there is not possible to have the centers. So, not possible to hold the workpieces. At that in that case, we need to do this centerless grinding. So, in centerless grinding, what we need to do, we need to have a hold the workpiece properly. So for that we used to have, for especially for internal grinding, we used to have these three wheels are provided. So these three wheels are using for holding purpose. So in that, this is the one is the regulating wheel, whatever we have seen, external or nothing but centerless surface grinding. So centerless cylindrical grinding, whatever we have seen yesterday. So there also this kind of regulating wheel is there. So here also regulating wheel is there. And in yesterday's grinding process, that is external grinding. So this grinding wheel is this side and this grinding wheel removing the material. But here grinding wheel is gone inside the workpiece because it is internal grinding. So that's why here we used to have two more supports are required. So these two supports is called as a pressure roll and as well as the supporting rollers. So these three rollers, what they're doing, they're just simply supporting the workpiece. They're supporting the workpiece by giving proper support, maybe three different, because any circle, if it normally centerless grinding, because inside a hole is there, so that hole we are grinding. So normally this kind of workpieces are bigger size. So maybe diameter of the pipe maybe somewhere about 2 meter or maybe 1.5 meter or maybe more than this. So these kind of big workpieces, when you're grinding, we need to have proper supports. So supports are providing three sides from outside. So this is a actually this is a regulating wheel which is controlling the movement of this workpiece. And these two rollers, what is the pressure roll as well as the supporting roll, this just hold the workpiece to in a position. So supporting roll is supporting, and whereas the pressure roll is applying the pressure so that this workpiece cannot be moved from this position. So only this regulating wheel is guiding the movement of this workpiece. So as these three are the outside, and inside this is the grinding wheel. Actually grinding operation is performed by this wheel. So grinding wheel. So this is a simple centerless internal grinding. The workpiece is supported between the three rolls known as the pressure roll, supporting roll, or regulating roll. Roll, or maybe you can call it as a wheel. So wheel or roll is same. So pressure wheel, supporting wheel, or regulating wheel, or pressure roll, supporting roll, or regulating roll. The meaning is same. So all rolls, whatever the rolls are there, these three rolls rotate in same direction. So because you see, so when your workpiece is rotating opposite direction, these things, so opposite to this workpiece, these three are rotating. So these three always rotating in the same direction. So the grinding wheel remain in contact with the internal surface of the workpiece. So this is the grinding wheel. This is always in contact with the internal surface. Then only you can remove the material from internal. So always it's contacting with this. The pressure roll is so mounted that it can be swing to slide. So whatever this pressure roll is there, so this is applying a pressure on that so that it cannot move out from its position. So mounted in that can be swung to slide, allow the loading and unloading of the workpiece. So this can be flexible. So this roll is fixed in its position, but this pressure roll, as it goes on, this can be moved. So maybe you can show this arrow. This can be moved so that once you move this pressure roll, and you can remove this object also. So this can move this direction as well as it is moving this direction. As if any problem is happening, so these wheel is applying a force on that, and it is maintaining the workpiece to be in this position. So these are the basic functions of these three, and this is the main function of grinding is happening by this. So this is a typical centerless internal grinding. In the question, if you ask you, so centerless internal grinding, maybe you can use this. So I hope I'm audible, right? So if any problem is there, please let me know. Okay. So in addition to this one, you used to have one more planetary internal grinding. So normally for smaller sizes, maybe somewhere about 1.5 meter, 2 meter, maybe you can have this centerless grinding. But when workpiece is very bigger, very big in size, very big objects are there, internally you need to grind it. So in that case, we used to have this planetary grinding, internal grinding. So this is typical, this is the planetary. Here, because your object is very big, so not required any kind of support, or maybe object is already fixed in its position. So not required, only you used to have a grinding wheel. So this grinding wheel is following a path. So path, it is parallel to the surface of internal, the whatever the workpiece, internal surface, parallel to the internal surface, it is moving. So this is following a planetary motion. So planetary path, that's why this kind of grinding is called as a planetary grinding. So planetary is nothing but your whatever the planets are moving around the stars or around the sun. So similar way you see. So there is a center point is there. So about the center point, this grinding wheel is moving. That's why this process is called as a planetary grinding machine, internal grinding. So grinding hole is a large, and maybe it is irregular because here we don't have any kind of supporting wheels are required. So not only circular, even for irregular surfaces also can possible to do planetary internal grinding. Irregular shapes and heavy, normally this used to do for heavy workpieces. So smaller workpieces and small in sizes, there may be kept on possible centerless grinding, but heavy workpieces we are using this one. The workpiece remaining stationary, which is mounted on a slide. The axis of rotating grinding wheel travel along a circular path around the axis of the hole. So whatever this showing, this is nothing but axis. So axis of the grinding tool. So this axis of the grinding tool is not stationary, it is moving. The grinding wheel is rotating about its axis. At the same time, axis also rotating about a particular path, right? So that is a parallel to the surface of the internal, parallel to the internal surface. So this is the axis of the rotation. Grinding wheel is travel along the circular path around the axis of the hole in the workpiece. The longitudinal travel is obtained by reciprocating movement of the grinding wheel spindle. So this, because in whatever the parallel to the surface, maybe you can see parallel to the screen. So here maybe, so this can be machining at that particular point. But if you want to move this, so this whatever the path is there, so path of this grinding wheel, it is not a circular, it is a spiral path. It is follow just like our thread cutting. When you thread cutting, how the thread is moving, it's rotating about its axis, at the same time it's moving forward. So this also following the same path, reciprocating movement of the grinding wheel of the spindle. So moving slide forwarded and backward on which the workpiece is mounted. Even not only that one, even your this whatever on which you are mounted the workpiece, that also can move forward and backward. So this movement, so sometimes you can movement is given to the grinding wheel, and sometimes your movement is given to the your workpiece. So depending upon the object, depending upon the size, as well as depending upon the arrangement, maybe you can move this. This is rotating about its axis and rotating about this path, as well as it is moving forward like a spiral. It is following in a spiral path. In some machines, if it is a comparatively small in size, the workpiece, then this is rotating about its axis, and this workpiece also can move forward and backward as it can reciprocate forward and backward. So what I tell you, so maybe you can take a screenshot of this. So this planetary internal grinding maybe ask you in the exam. So please take a screenshot, and after the class, maybe after the class, and when your today's classes are completing, so then maybe after that, maybe you can take it into a class notes. So this also please take a screenshot. So please, this also can take a screenshot. So these things I think available in your textbook also. Maybe if you want, you can refer your textbook. So these images are I've taken from the textbook only. So in textbook, maybe you have these images also. If asking you for the 5 marks question, definitely this one image you need to draw. So here also you need to draw this image. If it is a 5 marks or maybe 10 marks. If it is a 2 marks or 3 marks, maybe you can explain it. So in proper wording and proper form. So but if it is a 5 marks or 10 marks, maybe you can use to have the neat drawing, neat sketch is required. So the third internal grinding is chuck internal grinding. So normally this kind of grinding is required for a very small workpieces. So workpieces are smaller, especially in our workshops, in our the thing wherever is required. So there will not very big workpieces are there. Workpieces may be somewhere about 40 mm, 50 mm diameter. So where workpiece can be mounted on a chuck, then maybe you can use in check internal grinding. Directly you can mount your workpiece, so whatever the pipe or whatever the tubes are there, so directly you can mount as is shown in the picture. So directly you can mount on this. So this, because as this rotates, so this check is rotating, this workpiece is rotating. On other side of the center, so other side of tailstock, maybe you can insert your grinding wheel similar to your the drilling process. You insert it, and so this can, by rotating this, what are the workpiece and grinding wheel is in contact. So this is the stationary and this is rotating. So when one is rotating and one is stationary, definitely there is a relative motion is there. So due to this relative motion, there is a material removal is happening. The workpiece mounted on the chuck or magnetic plate. So not chuck or magnetic plate. Even chuck or magnetic plate both are same. So you mount the workpiece in the chuck or magnetic plate and perform on lathe. So this checking internal grinding can be performed on the lathe also. So right, so this is a very simple object for small in sizes. Maybe we are using checking internal grinding. So because it's inserting the workpiece in a chuck, that's why this process is called as a checking internal grinding. So fine, we can go for next slide. So these are the different types of grinding machines and grinding operations. So now maybe we can go ahead, because most important part of any grinding is grinding wheel, right? So other parts are just nothing but they're rotating this grinding wheel. So or maybe holding the workpiece at proper position. And main part of any grinding operation or grinding machine is the grinding wheel. So grinding wheel, as last class also I told you, it's a multi-tooth cutter. So grinding wheel is not a simple wheel, or not. It's not like a conventional cutter, whatever we have seen in the milling cutter or maybe in lathe cutter. It's not like that. It's a grinding wheel is a simple wheel. On wheel, you used to have abrasive particles are embedded. So each abrasive particle is acting as a tool. So here's a multi-tooth cutter it is. So that each abrasive particle is acting as a tool. So in that wheel, if you say there is thousands of cutters, so cutting tools are available. So these made of hard particles called abrasives. So whatever the cutting particles are there, that is very hard, because when it is hard, then only they can remove the material. So these particles is called as abrasives. So wheel has a one piece or segment of abrasive blocks. So as a last class also I told you. So this grinding wheel can make as a single wheel, a single part, or maybe you can join by multiple parts together. So finally, when you are joining multiple points together, so finally it is forming a wheel. So that wheel is calling it as a grinding wheel. If it's small grinding wheels is in a single piece. If it is a big grinding wheels, this is in multiple pieces are there. So these multiple pieces are multiple segments. So that is joined together and finally form a grinding wheel. So what material these grinding wheels are made of? Definitely there is abrasives are there. So abrasives are the very hardest material. So it is the material of grinding wheel which does not does the cutting action. So these abrasives are mainly the cutting tools in this grinding machine. So these abrasives are very hard, tough, and when fracture forms a cutting edges. So this whenever it's touching with the workpiece, it is forming a fracture in the surface of the workpiece and removing the material. So from the cutting edges, it is removing the material. So these attached to a wheel by suitable bonding material. So these whatever the small abrasives are there. So these small abrasives are bonded together. So by a bonding material. So that is called as a bond. So here in this, we can say that the grinding wheel is made of abrasives as well as bonding material. So what is the different types of abrasives? So these are the abrasives. Maybe you can see, maybe you can grinding wheels are look like this. So maybe it's smaller in thickness. We can call it as a cutter. If it's a bigger thickness, we can call it as a wheel. So even we can call it as a grinding cutter or grinding wheel. So if its thickness is smaller, so then you can call it as a grinding cutter. So if its thickness is bigger, then you can call it as a grinding wheel. So abrasives are hard substance which are used. So used as a cutting edges in the grinding wheel. Small abrasive particles called abrasive grains. So these abrasive particles are abrasive grains, the same thing. So abrasive grains are used in grinding wheel. So these abrasive grains are there, which is whatever the sharp edges of abrasive grain. So these sharp edges of the abrasive grains is acting as a cutting tools. So this is the machine tool is grinding. So cutting tool is nothing but whatever the tool we are using. Through that we are removing the material. So here whatever the abrasive particle, whatever the abrasive grains, so that the sharp edges of the abrasive grains is considered as cutting tools. So abrasives are classified into two types. So normally these abrasives, whatever the abrasives particles we are using, that is in two types. One is natural abrasive and second one is artificial abrasive. So natural abrasive means is directly get from the nature. We don't need to do any kind of preparation or any kind of things are is not required. That is called as a natural abrasives. Whereas artificial abrasives means it's made in proper by proper chemical reaction and proper processing. We used to make these abrasives. That is called as artificial abrasive. In artificial abrasive, most popular abrasives are aluminum oxide and silicon carbide. So these are the two abrasives which is more popularly we are using. In addition to that, some other artificial abrasives also there, like artificial diamonds. So for very hard materials, or maybe wherever the material removal rate is faster or is high precision is required, so there maybe you are using artificial diamond abrasives also, but that process is very expensive. So natural abrasive, if you take, so what is the natural abrasive? So natural abrasives which is available, which is we are going to get by in nature. So by controlled forces of nature, so sandstone, emery, corundum, diamond, natural diamond. So what are the natural diamonds? So even natural diamond also we are using as a cutting tool in some application. I told you in the starting of this subject. So here also the whatever the diamond naturally available diamonds also we can using as a abrasive particle. So sandstone or solid quartz is nothing but whatever the sand, the grains we can say, that is also used as a natural abrasive. So these normally using for hard operated grinding stones. So sharpening some wood or working tools. Normally these sandstones whichever is there, normally using for the soft material like wood, those kind of material we are using this one. Similarly, corundum. So corundum also one of the popularly used natural abrasives. So in this 75 to 90% is crystalline aluminum oxide, Al2O3 is present, plus small amount of 10 to 25% of iron oxide also there. So this corundum is getting naturally from the sea coasts. So this is we are not preparing artificially, just we are getting, and we are just we are crushing it to smaller in size, and we are using this. So similarly, natural diamond. So truing and dressing other grinding wheels. Normally diamond abrasives we are using to refining or nothing but truing of other grinding wheels, because grinding wheels, whatever the abrasive particles are very hard to do this. So to refreshing or maybe to controlling this, we need to have more high hard material. So for that maybe we are using diamond abrasives. So these diamond abrasives act as an abrasive material for hard materials. So emery also we are using normally in your MMS, metallurgy and material science lab. Maybe you are using emery papers. So for finishing of your workpiece surfaces, so that also naturally occurring material. So in that 50 to 60% is crystalline Al2O3 aluminum oxide is there, plus small amount of iron oxide. So here iron oxide in emery is more than corundum. That's why emery is normally is less stronger than corundum. So corundum is using for hard material, and emery we normally using for soft materials like aluminum or maybe for copper, this kind of material. Even for steel, some applications when we required very small amount of material is required, in that case we are using emery. So this emery normally we are using for polishing of workpieces, or nothing but polishing of your samples in our labs. So whether it's MMS lab or any other lab, whenever we want to see the microstructure of the material, so we need to finish the workpiece. So this finishing up, in that finishing we need to remove very small amount of material. So main intention of the finishing in labs, in MMS lab or any other lab, is to make your surface is a polished surface, so that under microscope when you're seeing, it has to visible properly. It has to be a flat surface. So for that normally we are using emery paper. So in that emery we used to remove very small amount of material, not very big lump of material. So coming to the artificial abrasives. So artificial abrasives normally we used to manufacture. So manufacture under controlled condition in closed electric furnace to avoid the introduction of impurities and to achieve the necessary temperature for chemical reactions to take place. So because as in the word itself it is there, so artificial abrasives. So these artificial abrasives we used to make in furnaces. So when furnaces, whatever the, for example, silica carbide, silicon and carbide has to add in the proper proportion and heat it to some particular temperature and hold it for sufficient time. Then there is a chemical reaction is happening between the two different elements, and they forming a bond between them. Silica carbide ionic bond. Silica carbide is ionic bond. You know, right? So silica carbide is forming. So not only aluminum oxide also is forming in the same way. So artificial whatever the abrasives are there, these abrasives are we are making in the labs, or maybe we are making in the workshops. So in the furnaces on the shop floor we are making. For that we need to have proper heat treatment. So proper heating conditions are required. Proper sometimes we need to apply proper forces also on them, especially for making a artificial diamond. So not only you require the temperature, you need to require the proper pressure also. So these temperature and pressure has to maintain in very long time. So in duration is maybe for hours, even sometimes we need to together in the weeks also we need to keep it. Then only you are going to get artificial diamond. So under these circumstances, when you make the abrasive particle, then only they can withstand that much high forces. So it's coming to be first most popular artificial abrasive is silicon carbide. So SiC. So it is made by silica sand. So silica sand is popularly available. So silica sand and powdered coke. So coke is nothing but whatever we are getting from the coal. So natural coal, we are going to get the coke. So this coke, silica sand and plus powder coke is mixed with salt, NaCl, whatever the normal salt we are using. So along with that, we used to have the sawdust. So all these things you can form together and you can heat this combination of this one into an electric furnace up to 4000 degrees centigrade. So because these things are not metals, all these elements are considered as a ceramic element material. When you're heating it up to 430 degrees, 4000 degrees centigrade, these materials may not melt. But because at higher temperature, normally material or maybe element is become more excited. So they need to form some chemical compound at that particular temperature. So this results when you're heating this temperature sufficiently, some standard time, then resultant a solid mass we are getting. So that solid crushed mass is treated with alkalis and made into grit. So after keeping this 4000 degrees centigrade, then crushed it. So and then we need to treat it with the alkalis and made into a grits. Grits are nothing but whatever the small particle sizes are there. So those small particle sizes it has to make. So these grid low tensile strength material like cast iron, bronze, copper, aluminum, plastic, etc. So these grids can be used to grind the material. Normally for soft material we are using not very high, very hard material like tungsten, but we are using for iron, bronze, copper, aluminum, even for plastic. So plastics also very small soft material. So plastics also nowadays using these grinding process. So for that we are using silica carbide. So next to silica carbide, is important popular artificial abrasives are aluminum oxide Al2O3. So most widely used. So these abrasive particles widely used because this is hard and you can remove material removal rate is faster for especially for the metals. So whereas aluminum oxide also can be applicable for the metal, but material removal rate is less. So that's normally for industrial application. Most popularly, we are using aluminum oxide. This aluminum oxide we are getting by fusing the bauxite and a small amount of coke in electric furnace. So so aluminum raw material of the aluminum is the bauxite. So directly when you are fusing the bauxite with in presence of coke, so we are going to get aluminum oxide Al2O3 in proper temperature and proper pressure conditions has to maintain. So this whatever the product we are getting, so finally it is the mass is crushed, and after crushing it is made into the small pieces and then washed it and heated with the alkalis so that whatever the impurities are there, so that impurities can removed. So after alkalis again it has to washed and then you need to grade it. So depending upon the size of the particles, maybe you can make it separately and you need to make the depending upon the requirement and depending upon the size of the grinding wheel, we can use this aluminum oxide abrasives. So high tensile materials like carbon steel, normally for high speed steels, Li steels, wrought iron, high speed steels, and tough bronzes where the strength of the material is higher. So they are normally using this Al2O3 aluminum oxide abrasive particles are using. Means grinding wheel made of aluminum oxide is using for hard material. So similarly, coming to the third important abrasive particles, what we are using, especially for very hard material, is using artificial diamond. So diamond produced through artificial means are quite comparable to the natural diamond in their grinding characteristics and give better result than the previous before, whatever the before Are you getting my voice?
Yes, sir. We are getting now. Yes.
So how long my voice was gone?
So you are explaining about
For 2 minutes.
degree of. Yes, sir. For 2 minutes.
Okay, okay. Maybe some network issues are happening because of that. Maybe I lost connection. I'll share again. So light here only I am there, right? When my voice is gone.
Yes, sir.
Okay, so aluminum oxide, so Al2O3 is made. Maybe if you want, maybe you can take a screenshot of this. So most popularly used grinding abrasive particles are aluminum oxide because this is harder than silica carbide. So this is using for even for metals. So hard metals also we can use. So fusing by I think this was there when my voice is gone. So artificial diamonds. So diamonds are also prepared by applying the very high pressure at a very high temperature. So continuously for very long time. So we are going to get the diamonds. So diamonds are made of completely carbon material. So even artificially also we can make the diamond. So this artificially made diamonds can use for grinding of the very hard materials. Even for grinding wheels. So these artificial diamonds are using. So So okay, then coming to be diamond. These are typical diamond wheels. Diamond wheels look like this. So in that these wheels are also made in almost similar shape as of the aluminum oxide or maybe silicon carbide wheels. They are also provided with the center hole so that it can be mounted on a spindle. So these are typical. So this is a typical lustral face. Maybe you can see these are diamond grinding wheels. So in that whatever the surfaces are there. So in that surface diamonds in very small in sizes, so that is embedded in it. So normally this kind of grinding wheels are using to grind very hard materials like tungsten or maybe to grinding the grinding wheels where you aluminum oxide and the silica carbides are there, and also it is using to grinding the diamonds also. So normally for grinding the diamond we are using diamond cutting tools only because other material cannot cut the diamond. So, and various types of bonds. Next important thing, when you're having the abrasive particles, so fine, abrasive particles are doing the cutting process. But these abrasive particles has to be bond together because these abrasive particles are very small in size. That is not in big. So these abrasive particles has to keep in the form of a wheel. So for that we used to have a bonding material. So bonds and various types of bonds are available in grinding process. So in order to give an effective and continuous cutting action, it is necessary that the grains of abrasive material should be finely hold together to form a series of cutting edges. Right? So for that, we used to have a separate material is required. That material is called as a bond. So bond is an adhesive substance used to hold the abrasive grains together in the grinding wheel. So whatever the abrasive particles are there that can hold together only by a bonding agent. If the proper bonding is not there, let's assume the whatever the abrasive particles, very hard abrasive particle with the natural diamond, silica carbide, aluminum oxide, or whatever is there, if it is not holding properly, what happens? Your this cutting tools are disintegrated into a small again individual pieces. The individual pieces is not possible to remove the material, right? So for that, you used to have a hold these abrasive particles together and perform the cutting action by whenever the wheel is rotating. So this cutting, whatever the abrasive particles are, abrasive sharp edges are there. So these edges apply force on the material and remove the material. So these bonds has to have sufficiently strong bonds are required. It's not like a weak bond. If it is a bonding is very weak, what happens when you're applying a force on the workpiece? During that time, instead of cutting the material, these abrasive particles may separate out from the wheel. So that's not supposed to happen. It may not wear, but it can separate because it is small. But whatever the abrasive particles are there, it may separate out easily if the bonding is weak. That's why we used to have sufficiently strong bond is required. The following are the few important bonding materials are using in the grinding wheels. So those things, maybe those bonding material is represented by letters also. So vitrified bond, silicate bond, resonite bond, rubber bond, and shellac bond. So in addition to these 5 bonds, oxychloride bonds also using. So each bond is represented by a letter. So to represent this bonding easily, when you buy when anybody is buying a grinding wheel, or maybe whenever as a design engineer when you're specifying a grinding wheel, you need to specify not only the abrasive particles, which kind of abrasive particles are required, in addition to that which kind of bonding is required. So each bonding in this whatever you're seeing the 6 types of bonds, so each bonding strengths are different. So bonding strengths are not the same. So depending upon material, what is the working material, and depending upon the size of the grinding wheel, your bonding type may change. So somewhere we are using vertified bond, somewhere using silicate bond, somewhere you used resinite bonds also is required. So these are the bonds. So the same bonds, whatever is represent. So this here maybe they're giving about characteristics of these bonding. If you take the vertified bond, it's very having very good strength and high porosity. So means it's a very high porosities are there, so that you can have a proper edges, cutting edges of abrasive grains can come out from the wheel and it can cut the material. Similarly, silicate bond is waterproof bond, whereas vertified bond is another waterproof. Normally for grinding of material of soft material, maybe normally we are using vertified bond. So even for wherever the water environment is there, wherever the humidity is higher, so there maybe we try to avoid the vertified bond. There maybe you can use the silicate bond, silicate bond. So this is waterproof, used for large diameter wheels. Normally for very high size wheels, maybe we can using the silica bond. So grinding of fine edge tools, etc. is using fine tools. Normally grinding wheel of tool is very hard material. So for this hard kind of material, they used to use this silicate bond. So silicate bond is represented by S, vitrified bond is represented by V, shellac bond. So shellac bonds normally using for thin wheels. So whatever the grinding cutters are there, so these grinding cutters normally is bonded by the shellac bond. So thin wheels, high elasticity. So here normally compared with previous two bonding, so in this shellac bond you having a higher elasticity. So this higher elasticity required for especially for disc. So grinding disc or grinding cutters wherever you are using. So they, for that we are using shellac bond. It having a good elasticity, not suitable for heavy duty applications. For very thick wheels, grinding wheels, normally we are not using shellac bond. So heavy duty applications we are not using, but normally for cutting or maybe starting or maybe grooving, wherever only one part, a small portion of the material, portion of the workpiece, you need to remove the material. So there we are using this shellac bond. So then the resinite bond. So rough grinding for high speed grinding, normally we used this kind of resinite bond. Resinite bond is represented by B. Shellac bond is represented by E. So here you see it's not represented by first letter of this one. So you need to be remember this. Vitrified bond and silicate bond is represented by their first letter, but resinite bond and shellac bond is not represented by its first letter. So different because it's shellac bond is elastic band, that's why it's represented by E, and resinite bond is used for basic purposes, so that's why it's represented by B. And similarly, rubber bond, rubber bond is using normal rubber material. So thin wheels, fine finishing and polishing, etc. Wherever the polishing is required. So ball bearing races, so there maybe rubber bonds are is using. Rubber bonds also elastic. It's soft in nature, but it's not using for normally higher temperature. So normally for low temperature, for only for thin wheels, we are using rubber bond. So rubber bonds as well as the shellac bonds are using for wheels. So rubber bond represented by R, and similarly for oxychloride bond. So disc grinding, it's a less brittle. So oxychloride is normally for special purposes only we are using. So this is represented by O. And okay, okay. So we'll go for this. We will individual grinding we can see in brief, and then maybe we can go for other processes. So vertified bonding process. So the clay and abrasive grains are thoroughly mixed with sufficient water to make uniform mixture. How these bonds are made? So that explanation is there in this. So the clay and abrasive. This is normally vertified bonds is made of clay. So clay is mixed with abrasive grains and thoroughly mixed with sufficient water to make uniform mix. The fluid mixture is then poured. This whatever the semi-solid or nothing but slurry is poured into the mold and allowed to dry it. So because it's added a water, so if you keep this slurry for sufficiently long time, so water is what happened. Water will evaporate from that, and remaining you need to have the clay and your abrasive particles. So after cooling, the material trimmed to more perfect size and shape. Once you are made it as in the mold, and after removing the mold, so whatever you're doing in the casting, same kind of thing. Maybe you can remove if any kind of excess things are there that can be removed, and then we can use it. So this heated in a furnace to a temperature of 1260 degrees centigrade. So these clay vertified in furnace to form a proclaim or glass-like substance that surrounded the connecting the abrasive grain. So whatever this vertified bond is there, it is look like a transparent kind of thing. So some kind of things are there. So the like a glass kind of mixture is formed at the end when you are heating to this temperature and holding some time and cooling down. So denoted by V. So this vertified bond is denoted by V, but it gives a very good strength and porosity to allow high stock material. So for wherever you are using for rough grinding or maybe material removal is higher, so there you are using for this vertified bond. So this vertified bond normally not using for very hard material. Soft material it is using. Maybe the metals or plastics, but normally for soft material, rough grinding, we are using this. So this is a, so making this kind of wheels are tedious process. So so this making a grinding wheel is similar to your casting process. You need to mix it, a bond binder. You need to mix it some fluid to act as a if a abrasive carrier, and then pouring into the required mold and then allowing it to the solidify. So it's a tedious process. Working speed normally we are using because this fortified bond is not using for hard materials. For general purpose grinding we are using. Normally we may not use wherever the grinding wheel speed is more than 200 meters per minute or nothing but 200 meters per minute or in second maybe divided by 60 you can see. So that much speed. Now if that exceeding that speed, your bonding strength may decrease. It can easily remove the abrasive particles. That's why we cannot use for very high speed and high strength materials. So then coming to silicate bond. So silicate bond is stronger than vitrified bond. Silicate bonding wheels are made by mixing the abrasive grains with sodium silicate or water glass. Sodium silicate is also called as a water glass. So mixing with these abrasive particles, mixing with sodium silicate. The mixture is packed in a mold and allowed to dry. So packed in a mold and we need to allow to dry. So because normally it is happening at higher temperature. So at this temperature where your sodium silicate is in the liquid form, so in that we need to pour into the mold and it allowed to solidify. The mold shapes are baked in a furnace at a temperature of 260 degrees centigrade for several hours. So after cooling down, it has to be placed into a furnace at 260 degrees centigrade and keep at 260 degrees centigrade for very long time. So when it's formed this bonding agent is forming a very strong bond among themselves, and as well as it's properly holding the abrasive particles. So this is denoted by S. Silicate bond is denoted by S. So it's very rapid process than vertified bonding. In the vertified bonding, normally what you used to do, you need to heat it to almost 1400 degrees centigrade. But here it's not required that much high temperature. That's why this process is faster compared with vertified bond. So mechanical strength compared with the other bonding, maybe it is comparatively less, but compared with vertified bond, it's